Okay, so we are going to start today with the nutrition lecture. It may be in a few more different pieces, so you may see me in different outfits just because I'm doing a little bit at a time. We're starting with the macronutrients. Macronutrients are the three major categories of nutrients: the carbohydrates, proteins, and fats. You need to know some sources for each of those, and you know the major purposes of each in the body. So we're going to start with carbohydrates. Carbohydrates are classified as either simple or complex carbohydrates. Simple carbohydrates either are glucose or they break down to glucose very quickly. Complex carbohydrates are longer chains and take longer to break down. There are some complex carbohydrates that will not break down in the human GI tract, like fiber. Those fiber molecules stay intact, and that has quite a bit of benefit in maintaining the health of our GI tract. It adds bulk to the stool, holds water in the stool so that constipation is less likely, and it helps prevent some, it helps to prevent GI tract cancers. So when we're teaching patients about eating healthy, we want to talk to them about simple versus complex carbohydrates, because simple carbohydrates tend to bring the blood sugar up quickly, bring blood glucose up quickly because they break down to glucose very quickly. So think about things like sucrose. And we also tend to have a quick drop in blood glucose. Complex carbohydrates break down more slowly, so they take longer to raise blood glucose, but they also tend to maintain a steadier blood glucose level. In general, it's usually healthier to eat more complex and fewer simple carbohydrates, but there are situations when a simple sugar is the most appropriate treatment. For example, if someone is having symptomatic low blood glucose, we want to get a simple sugar into them quickly to get that up, and then follow with a more complex carbohydrate. So carbohydrates are the body's basic primary source of energy. So because of that, they tend to be a large portion of the diet. Carbohydrates that are not used immediately for energy, that energy is converted and stored as body fat. So sometimes we kind of go through phases in popularity with whether carbs are considered good or bad, fats are considered good or bad. In the 80s, it was all about low fat, so people were encouraging pasta and rice and things like that. Now it's more about low carb, and so people are encouraging patients to eat more fats and proteins and less carbs. And what we really need to do is balance that somewhat. We do need a significant amount of carbohydrate in the diet to maintain enough energy for body processes. If we don't have enough carbohydrate, then our next step in obtaining enough energy for our cells to work is breaking down amino acids. So that can either be from the protein that we consume, or it can be by breaking down muscle tissue. And then finally, if we still aren't getting enough glucose to provide energy for our cellular processes, then we start to break down fats. And when we begin to break down fats for energy, we actually end up with a byproduct called ketones. So if you studied a little bit about the pathophysiology of diabetes, the primary problem is that we cannot get glucose into the cells for energy. And so we start to break down other sources of energy. And when we get to break down to the point where we're breaking down fats for energy, and that's our only energy source, then we end up in diabetic ketoacidosis. So the primary purpose of carbohydrates is energy. Proteins are used to build body cells and tissues. Inadequate protein intake can lead to muscle deterioration, muscle atrophy. It can lead to increased risk of infection because adequate protein is required to build white blood cells. It can lead to shifts in body fluid, if we don't have enough protein in our vascular system, in particular albumin, specific protein that we need in the vascular system, then fluids will go out of the vascular system into the tissues and we have ascites. So there's several complications from inadequate protein. Protein also tends to slow down carbohydrate metabolism. So for your patient that has trouble regulating blood glucose, you want to have them eat those carbohydrate meals or snacks with some protein to try to slow that metabolism down. Proteins are listed as either complete or incomplete, and that's based on whether they have all of the essential amino acids. What are the essential amino acids? Proteins are made of amino acids. Some of those amino acids can be synthesized by the human body. Some of them cannot, which means we have to get them from through the diet. So we call the ones that cannot be synthesized in the body essential amino acids. A complete protein contains all of the essential amino acids, meaning the ones that cannot be synthesized by the body. An incomplete protein does not contain all of the essential amino acids. So that doesn't mean that it's an unhealthy food. That means that we have to have another source for those amino acids that are missing. So someone who eats a vegetarian diet frequently looks for complementary protein pairings, because the majority of foods that are complete proteins, meaning they have all of the essential amino acids, are animal-based foods. So if we're looking at plant-based foods, most of them are incomplete proteins. So there are some traditional pairings that actually complement each other. Complementary proteins means that between the two foods, they have all of the essential amino acids. One example of that is beans and rice. Some form of beans and rice is consumed in many, many cultures in the world. And that when those are consumed together, then all the essential amino acids are in that pairing. And so those are considered complementary proteins. Fats are essential for the function of the nervous system. The myelin coating that's on a lot of nerves, a lot of the nervous system is a lipid coating. So inadequate fat intake, in particular in the formative years, in the first 2 years of life, can have neurologic impact. Fats also maintain some vitamins in the body. There are vitamins that are water soluble and there are vitamins that are fat soluble. So fats are necessary for transport and storage of those fat soluble vitamins. Fats are listed as saturated or unsaturated, and that has to do with the chemical formula. But one common way that we look at to try to tell those apart is that most saturated fats are solid at room temperature. Most of them are also animal-based, so think butter, lard, okay? Most unsaturated fats are from vegetable sources, and most of them are liquid at room temperature. So we learned a long time ago that those unsaturated vegetable-based fats are tend to be healthier. There are some fatty acids that are best obtained through those. But we really like that smooth, spreadable, solid consistency. And also around this time that margarine was developed, butter was really expensive. And so scientists discovered a way to take those unsaturated fats and turn them into a solid. So we developed margarine and shortening. Well, it turns out that when we take unsaturated fats that are normally liquid at room temperature and we turn those into a solid, something called trans fats is created. And trans fats actually cause greater health damage than saturated fats. So that's where the trans fat thing came along. There now are legal limitations in some places on how many trans fats can actually be in products. So for those macronutrients, you need to know the most common food sources. When I say a food, what kind of macronutrients are in that food. And you need to know the basic purpose of each of those macronutrients. In the next section, we're going to talk about micronutrients.